Howdy everyone, and welcome to our next retake review video. So in this one, because we've established, because I posted the retake versions of all the quizzes so far, I'm going to be going over the original version of the quiz. Now that I can actually give you all the answers with no worry, right? So this is the topic 9 and 10 quiz. This one tripped up a lot of people, and let's talk about what happened there and how we can address it and what were the major trip ups. Okay. Now, for the topic 9 and 10 quiz, we did a little bit of topic 9 at the top here, and then we did mostly topic 10 stuff. So this was the second topic 9 quiz, and then the first and only topic 10 quiz, right? So now that we're examining this, let's kind of look at what happened with some of the most commonly confusing questions, starting with 1 and 2. Now, when I'm going over these, remember, as I've been saying in the other review videos, well, maybe not remember, maybe you didn't see those ones, right? Maybe this is the only one you need help with. I'm not going to be going through a lot of the details, okay? So I'm not going to be explaining, what are the 4 triangle congruence postulates, or what is a correspondence or congruence statement. I'm going to be giving as much reason and justification as you would need to solve these problems, but that's assuming that you have a good filled out notebook and you have a good understanding of the materials and ideas presented here. If some of the stuff we're going over is absolutely confusing, like you just don't know what a triangle congruence postulate is, right? Or you don't know what a correspondence statement is, then you should review the videos on those things, right? Once you have a good understanding of those concepts, you can come in here and see how we apply and use those concepts, okay? So without further ado, let's check it out. Let's go over number 1. Number 1 is one that most everyone got correct. I think most people did this one pretty good, but there was still a couple of hiccups, so let's check it out. So we need to use the correspondence and congruence statement here, right? Remember, correspondence and congruence statements, there's a couple typos hiding here. Let me fix that. Correspondence and congruence statements, they have a certain order, and that order is important, right? So we're going to use the order to figure out these problems, okay? So for example, side HJ is congruent to what side on the other triangle, given that these two triangles are congruent? Well, because the order is important, HJ, the first 2 letters, matches up with EF, the first 2 letters of the other one, right? Likewise, EG is the first and third letter, so it's going to match up with H and K. Good. Okay, what about angle H? Well, angle H is the first letter, so that's going to match up with angle E. Then angle F is the second letter, so that's going to match up with angle J. And then FGE, that could be like an angle or a triangle of its own, right? That is FGE, that's the second, third, first letter, so it's going to be JKH. And there you go. Pretty fast, right? Just by looking at that one statement we were given, we were able to get all of this information. That is why we have the order important for these things, right? That's why we're so finicky and pedantic about it, because with that one piece of information, you get all of that. Okay, what about for number 2? For number 2, again, we have a correspondence and congruence statement. Probably should have triangles here. Again, some typos, as whenever we export, you lose a symbol here and there, right? Now, we need to solve for these 5 problems. But notice, unlike before, I'm going to highlight this, unlike before, where we had a congruent symbol, now I have an equal sign. And I don't have a bar over my 2 letters. I have, well, nothing, right? These are all hints that I am not looking for you to tell me the pair of points or whatever that this matches up with. I'm not looking for a side. I'm looking for a measurement. So this question is not what is SU corresponding or congruent to. It is SU is equal to what? Because here, this is not the side SU. This is the side length of SU, the point S to the point U. So here, SU, what is the length of SU? Well, it's not recorded here, but I do have a congruent statement and some measurements in the other triangle. So SU, first and third, corresponds to PR, which is 7 meters. That means SU is also 7 meters. Handy. ST, the first 2 letters, is to SPQ, which is 8 meters. Easy, right? Well, maybe not easy, but straightforward is a better way to put it. 1 step, right? Maybe 2 steps, really, because you're finding congruence and then the measurement. Now, where it's going to get a little trickier is in the angles. What is the measure of angle S? Well, S corresponds to P, and P is 59 degrees. Yeah, it's a 2-step process, right? But where it's going to get trickier is when I do R. What is angle R? Well, R corresponds to U, but U is also not given to me. However, I did learn what S was just now, which means I could figure out what U is. Remember, by using the triangle sum theorem, right, 180 equals 59 degrees plus 75 degrees plus the measure of angle U, right? I can figure this out. Well, I'm going to take away 59 from both sides. I'm going to take away 75 from both sides, right? Basically figure out how much is left to be able to get to 180, because I need to figure out what am I going to need to add to get these both to get to 180, right? Whatever is left over. That's why I need to take away both sides. So I get 121 minus 70 is 51 minus 5 is 46 degrees, I believe. I messed up a little bit, but I think that's right. Probably should use a calculator, right? But I can check. So 59 plus 75, 5 plus 9 is 64, plus 6, that's 70. See, I messed up, right? That's not right. I must have messed up somewhere. So let's double check. See, this is why we double check. So let's see here. 59 plus 75, that's going to be 125, 134, right? Yeah, that was right. I did have it right. Okay, see? We double check our work just to be safe. So I get 46 degrees here. And then the measured angle Q, well, that's the last one here. We just found R, right? So Q is not 59, not 46, so that leaves the 75. Because if I look up here, it's the middle, and T was 75. There you go. So what were the trickiest steps there? Well, one, you need to establish that these are all asking for measurements, right? These are equal signs. There's an M in front of the angle, and there's no bar. So you need to be giving me numbers, right? Not sides, not angles, but numbers. And two, you had to use the triangle sum theorem at one point, right? That's a thing that we've been using a lot, and remember the whole video on it. But I would really make sure you know the triangle sum theorem at this point, because whenever you have a problem like this, like, ooh, I know these two, but not that, you need to know you're using the triangle sum theorem. And we need to know that I could use 59 there, right? To remember that I just found what 59 was, so I can use it. All right, the last four problems are all triangle congruence postulate problems, okay? So again, I'm not going to go into super big detail about triangle congruence postulates, what those are, how they work, but I am going to show you how you use them to solve a problem, okay? So right here, what method can be used to prove that triangles below are congruent? Right off the bat, I'm given a side pair, right? A pair of congruent sides and a pair of congruent angles. Well, because I'm given a pair of congruent angles, I'm not likely going to use side, side, side. I could, maybe, so I'll come back to that if I have to, but it doesn't look like I'm going to use that because I'm probably going to use the angle they've given me. So I'm trying to pick between not possible, angle, side, angle, or angle, angle, side. Well, if I was just to stop here, right, this would not be possible because I only have two pieces of information, not three. But is there something about the construction of these triangles that can give me another piece of information? There is. I have a vertical angle relationship here. And remember, vertical angles are congruent to each other. So anytime I see two triangles touching tips like this, right, if they're touching corners, that is a vertical angle relationship. And touching a corner like that means that they are congruent, which has given me two angle pairs and a side pair, right? So now, again, ASA, AAS, which one is it going to be, right? Because they both have two A's and an S in them. So I got to make sure I'm looking at the order of the points, right? So going around the triangle, I need to make sure that every side is touching an angle that I'm using, or every angle touching another angle or another side, right? I've got a side here, an angle here, and an angle here. And likewise over here, I have the same order of provided information, just the other way around. So AAS, AAS, that is AAS. It's not angle side angle because my side is not between my two angles. You see that? This would be angle side angle, but it's not that. That is angle, angle, side. There you go. So it's not impossible. A lot of people thought that was impossible. Then a lot of other people told me it was angle side angle. You got to make sure you're recognizing not just that it is possible, but that it is in the right order as well. Okay, next up. For 4, what do we got? Well, 4 has some parallel lines given to us. So we're going to need to use our parallel line relationships, right? So let's break this down into some sets of parallel lines together. I have a parallel line here and a parallel line here and a transversal going through the middle right here, right? So by using my parallel and transversal angle relationships, I know this. I know that alternate interior angles are congruent to each other, right? Now, what else do I know? Well, not much, right? So that's about it for that one. But I do know the other way around, right? I know that this is congruent to this. Okay, so maybe that'll come in handy in a second. And I think it will. Check this out. With just one pair of parallel sides, right, and this shared side in the middle, oh, see, shared side, is a side congruent to itself? Well, the definition of congruence, remember, is having the same measurements, right? And does a side have the same side length as itself? Yeah, right. If the side length is 5, then it is congruent to itself. Things are equal to themselves and they are congruent to themselves. That's one of the properties we learned. So now I've got angle side angle on the left and angle side angle on the right. This is an angle side angle relationship. Cool, right? Fast, easy. And I could have done the exact same relationship this way. This pair of parallel lines have the exact same things happening, right? Very convenient. That's how we got the orange ones, you see? But by using both of them together, we're able to get enough piece of information. They didn't give me a single angle here. Only the side in the middle that was shared was known to me. But by using the parallel lines, I'm able to get that. This tripped up a lot of people because I think, again, not a lot of people did very good on the parallel lines and transversal stuff. I think that was tough for us. So this tripped up a lot of people. All right, next up, 5 and 6. What method can be used to prove the triangles below are congruent? Well, looking at this, I've got an angle, a side, and then a side, right? So A, S, S. And over here, I've got an angle, a side, and a side, A, S, S, right? Is that congruent? Is ASS or SSA a valid triangle postulant? Well, it's not one of the answers on the right. So that should be a very good sign that it's not, right? Notice it is not SAS because, here's the problem, I got side, side, angle, not side, angle, side. If the angle was here, that would be SAS, but it's not, right? That is SSA or ASS, right? And remember, you're not allowed to have fun in math class, no bad words. So if you see SSA, right, that's not a valid triangle congruence postulant. You can't use that, right? So that's not possible. It's not possible. We can't get any other angles here, so neither of these are possible either, right? There's nothing else to give me an angle here. It's just not possible. Okay, next up, what else do we got? Our very last problem is 6. So right here, I've got what method can be used to prove the triangles below are congruent? Well, a lot of people said HL, but you can't use HL. Why not? So for one, not a lot of people saw HL because it was bonus in our notes. We didn't actually go over it. It was just passingly mentioned, right? It was kind of a bonus. But HL is only used when you have a right triangle. We are not told that this is 90 degrees. It could be 90 degrees, but we're not told it's 90 degrees. It could be 91 and 89 degrees, so imperceptibly different that you can't tell. But it's not given to us, so we can't use HL. We don't know this is a right triangle. Okay, what does that leave us with? Well, we got two sides given to us, two side pairs, right? So I either need to find this angle is congruent to this angle to get side angle side, or I need to find another side. Well, there's no angle relationship we can use to connect this angle to this angle, right? That's just not a thing we can do. So it might just not be possible, but remember, we have a shared side. When two triangles are touching sides, shared sides are congruent to themselves. So this is indeed a third side that we know is congruent, which gives us side, side, side. Most people got this one, but not everyone did, right? It was a little tricky, especially with HL, but you cannot use that one, okay? So there you go. That is all of the topic 9 and 10 quiz, all the triangle congruent postulant problems. I would really recommend going over the triangle congruent videos if that did not make sense. Likewise, for these two, I would recommend looking at our correspondence congruent statement videos and going over notation if this part really tripped you up. If you didn't know you were supposed to be doing measurements here, remember to go over the notation in the very beginning of the course. A lot of people forgot that kind of stuff over the course of the year, but that notation is very important. Okay? Hope you have a good day. If you have any questions or concerns, please email me. Super happy to help out. And review any videos from the past. If you just need to check in on some of the concepts, then try watching this video again and see if it makes more sense. Have a good day.